Let's go.
Assalamu alaikum friends. Welcome to my YouTube channel Technical Knowledge for DevOps, Technical Knowledge at D. In today's video, we will go through some real-time Kubernetes interview questions and their answers to help you prepare confidently. Let's get started. Question 1. What is the difference between Docker and Kubernetes? Answer. Docker is a containerization platform that allows developers to package applications and their dependencies into portable containers. It focuses on building, running, and managing individual containers. Kubernetes, on the other hand, is a container orchestration platform that helps manage and deploy containers at scale across a cluster of machines. It offers advanced features such as self-healing, autoscaling, load balancing, rolling updates, and service discovery. In simple terms, Docker helps you create and run containers. Kubernetes helps you manage containers in a production environment efficiently. While Docker is often used in conjunction with Kubernetes, they serve different purposes in the container ecosystem. Question 2. What are the main components of Kubernetes architecture? Answer. At a high level, Kubernetes architecture is divided into two main components. 1. Control plane. The control plane is responsible for managing the overall state of the cluster. It makes global decisions about the cluster, e.g., scheduling, and detects and responds to cluster events. Key components of the control plane include API server acts as the front end for the Kubernetes control plane. All communication happens through the API server. Scheduler assigns newly created pods to suitable nodes based on resource availability and other constraints. Controller Manager runs background controllers that handle routine tasks such as node management, replication, and endpoint updates. Cloud Controller Manager (CCM) integrates with cloud providers to manage resources like load balancers, volumes, etc. ECT, a consistent and highly available key-value store used as Kubernetes backing store for all cluster data. 2. Data plane, node components. The data plane runs on each node and is responsible for running the actual workloads, containers. Key components include kubelet, an agent that runs on each node and ensures containers are running as expected. Kube-proxy handles networking and load balancing, maintaining network rules for pod communication. Container runtime, software responsible for running the containers, e.g., Docker, containered, CRAO. Question 3. What are the main differences between the Docker Swarm and Kubernetes? Answer. The main differences between Docker Swarm and Kubernetes lie in their features, scalability, and ecosystem support. 1. Scalability and complexity. Kubernetes is highly scalable and better suited for large, complex environments. It supports advanced features such as autoscaling, self-healing, and rolling updates. Docker Swarm is simpler and easier to set up but is less suitable for large-scale, production-grade deployments. 2. Networking. Kubernetes offers a powerful and flexible networking model with support for network policies, service mesh integrations, and ingress controllers. Docker Swarm provides basic networking features with limited control over traffic routing and policies. 3. Ecosystem and community. Kubernetes has a vast and mature ecosystem with strong community and third-party tool support, e.g., Helm, Prometheus, Istio. Docker Swarm has a smaller ecosystem and limited third-party integrations. 4. Load balancing and service discovery. Kubernetes provides advanced load balancing, DNS-based service discovery, and external traffic routing via ingress. Docker Swarm supports basic load balancing and service discovery, but lacks many advanced traffic management features. 5. Learning curve. Kubernetes has a steeper learning curve due to its complexity and rich feature set. Docker Swarm is easier to learn and suitable for smaller teams or simple container orchestration needs. In summary, Kubernetes is preferred for large-scale, production environments due to its robustness and flexibility, while Docker Swarm is a lightweight option for smaller or simpler setups. Question 4. What is the difference between Docker container and a Kubernetes pod? Answer. A Docker container is a lightweight, standalone executable package that includes everything needed to run an application: code, runtime, libraries, and dependencies. A Kubernetes pod, on the other hand, is the smallest deployable unit in Kubernetes and represents a wrapper around one or more containers that share the same network namespace and storage volumes. Key differences. Scope. A Docker container is a single container running an application. A Kubernetes pod can run one or more containers that are tightly coupled and need to share resources like network and storage. Definition. Docker containers are defined and run using Docker CLI or Docker Compose. Kubernetes pods are defined declaratively using YAML or JSON manifests, which makes configuration and automation easier. Networking. Containers in a pod share the same IP address and port space, allowing them to communicate via localhost. Docker containers by default have isolated networking unless explicitly connected. Use case. A container is the basic building block. A pod is the basic deployable unit in Kubernetes that manages containers in a more structured and scalable way. In summary, a pod is a higher-level abstraction that wraps around one or more Docker containers to run them as a cohesive unit within a Kubernetes environment. Question 5. What is a namespace in Kubernetes? Answer. In Kubernetes, a namespace is a way to logically isolate and organize resources within a cluster. It allows multiple teams or projects to share the same Kubernetes cluster without interfering with each other. Namespaces isolate resources, pods, services, config maps, etc. Network policies. RBAC, role-based access control. Resource quotas and limits. Example use case. Suppose two different teams are deploying applications on the same Kubernetes cluster. Team A uses namespace NS1. Team B uses namespace NS2. They can manage their own resources independently, apply separate access controls, and avoid name collisions, e.g., both can have a service name frontend in their own namespace. Key points. Useful in multi-tenant environments. Helps enforce security boundaries and resource governance. Namespaces do not provide hard security boundaries like separate clusters but are effective for logical separation. Question 6. What is the role of kube-proxy? Answer. Kube-proxy is a key component of the Kubernetes networking model. It runs on each node in the cluster and is responsible for service networking and traffic routing. Key responsibilities. Maintains network rules using iptables, IPs, or eBPF to allow network communication to services. Routes traffic to the appropriate backend pods based on the service definition. Handles load balancing for traffic directed to a Kubernetes service. How it works. When a client sends a request to a Kubernetes service, kube-proxy intercepts the request on the node, looks up the corresponding endpoints, pods, for the service, forwards the request to one of the backend pods using round-robin or another routing strategy. Summary. Kube-proxy ensures that network communication between services and pods works seamlessly across the cluster. It dynamically updates routing rules as services or pods are added, removed, or modified, maintaining consistent service discovery and communication. Question 7. What are the different types of services within Kubernetes? Answer. In Kubernetes, a service is an abstraction that defines a logical set of pods and a policy to access them. Kubernetes offers several types of services to expose applications based on different use cases. 1. Cluster IP, default, exposes the service internally within the cluster. Accessible only from within the cluster using the cluster internal IP. Ideal for internal communication between services. 2. Node port. Exposes the service on a static port on each node's IP. Accessible from outside the cluster using node IP node port. Commonly used for development or limited external access. 3. Load balancer. Provisions an external load balancer through a cloud provider to expose the service to the Internet. Automatically assigns a public IP address. Best suited for production workloads requiring external access. Additional service types, optional to mention. External name maps a service to an external DNS name. Headless service, cluster IP, none used for direct pod-to-pod communication, especially in stateful sets or when using service discovery tools. Question 8. What is the difference between node port and load balancer type service? Answer. The main difference between node port and load balancer service types lies in how they expose applications outside the Kubernetes cluster. Node port. When a service is created as a node port, Kubernetes allocates a static port from the range 30,000 to 32,767 on each node's IP address. The kube-proxy updates the iptables, or IPVS, rules to forward incoming traffic on that port to the appropriate backend pods. Users can access the service externally using node IP node port. Requires manual management or external load balancer configuration if high availability is needed. Load balancer. When a service is of type load balancer, Kubernetes interacts with the Cloud Controller Manager (CCM) to provision an external load balancer using the cloud provider's infrastructure. The service gets an external IP address through the cloud provider, e.g., AWS ELB, Azure Load Balancer, GCP Load Balancer. Traffic to this external IP is automatically routed to the service's back-end pods via the cloud-managed load balancer. This is the most convenient method for exposing services publicly in cloud environments. Summary. Node port exposes service via static port on each node. Requires manual routing or external LB. Load balancer automatically provisions a cloud load balancer and provides a public IP for easy external access. Question 9. What is the role of kubelet? Answer. Kubelet is an essential component of the Kubernetes node architecture. It runs on every node in the cluster and is responsible for managing the lifecycle of containers on that node. Key responsibilities. Pod management. Kubelet receives instructions from the Kubernetes API server about which pods should be running on its node. Container monitoring. It monitors the status of containers and ensures they are running and healthy. Desired state enforcement. Kubelet constantly checks whether the current state of the node matches the desired state as defined in the pod spec. If not, it takes corrective actions such as restarting failed containers. Resource coordination. It ensures the required resources, CPU, memory, etc., are available for containers, and reports node-level resource usage to the control plane. Health reporting. It sends status updates back to the API server about the health of pods and the node itself. In short, kubelet acts as the bridge between the control plane and the container runtime on each node, ensuring that workloads are running as intended. Question 10. Day-to-day activities on Kubernetes? Answer. As part of the DevOps engineering team, we are responsible for managing Kubernetes clusters within our organization. Our day-to-day activities include ensuring that applications are properly deployed and running smoothly on the Kubernetes platform. We have implemented robust monitoring and alerting systems to proactively detect and resolve issues within the clusters. When developers encounter problems, such as issues with pods not running correctly, services not routing traffic as expected, or general debugging challenges, they rely on our expertise to troubleshoot and resolve these issues effectively. In addition to support, we handle various maintenance tasks. For example, our Kubernetes setup includes 3 master nodes and 10 worker nodes. We regularly perform maintenance such as upgrading Kubernetes versions on worker nodes, installing necessary security patches and mandatory packages, and ensuring the nodes are protected against vulnerabilities. We also act as subject matter experts for Kubernetes within the organization. When other teams face challenges or need guidance, they typically raise Jira tickets or service requests, and we assist by resolving the issues or helping them understand Kubernetes concepts and best practices. Overall, our role involves a combination of platform management, troubleshooting, support, maintenance, and knowledge sharing across teams. I hope you found this video helpful. If you did, please like, share, and subscribe to Technical Knowledge for DevOps Engineer channel for more valuable content. Channel name, technical knowledge at DE. Thanks for watching and Jazakallah khair.